So here I have a function. Here's its output. And if I'm trying to generate a derivative function, let me go back to my definition. That is to say, the limit of a difference quotient. Now, evaluating my function at x plus h, I have the following. I will simplify what's in the limits position. Certainly, I have cancellation here, as well as here, as well as here. Now, I should have said at any stage of the game, if you want to take a break and evaluate the limit, please go for it. It's just that at every single stage of the game so far, you're simply getting a 0/0 situation. So I have to keep pushing and massaging what's in the limit so that I remove myself from being in that indeterminate form. If I pull out a factor of h from these three terms in the numerator, cancel with the one factor of h downstairs, I now have this limit. Now that I remove the problem child upstairs and downstairs, that is to say, I removed the factor of h upstairs and downstairs, that's why I was in the indeterminate form, I will now evaluate my limit. There's a derivative function. Now, graphically speaking, it kind of makes sense. That's a parabola. Looks something like that. And its derivative function right there is a line. Looks something like this. Which kind of makes sense because at the vertex, my tangent line has a slope of 0, so the y value on the graph of derivative function should be 0 as well. On the original function f, anywhere to the left of that vertex, slopes of tangent lines are all negative, getting more and more negative as I move to the left, which is exactly what's happening with the y values on the line. Something similar is happening on the right-hand side of the vertex. So, looks reasonable. Now, next on my list, before I stop, please, for anybody who understands a bit of the differential calculus, I am not yet looking at the shortcuts for the differentiation process. So if some of you out there are saying, why don't we just use a power rule term by term to come to the derivative function? You'd be absolutely correct, but for now, I want to use my man-made definition, that is to say, this definition. Oh, sorry, I got rid of it. My apologies, that was the last video. As a matter of fact, how about if I give you a guarantee? On the next exam, I guarantee you one of the questions will be, given a function f, find its derivative function using our formal definition of derivative. That is to say, using the limit of a difference quotient.